Hello everyone, and welcome to this Active HDL tutorial. My name is Chantel, and for this video I am going to be covering toggle coverage. And it's basically a type of code coverage that Active HDL offers that measures design activity in terms of changes in signal logic values. So this includes scalar and vector system Verilog objects, as well as VHDL objects like Boolean, bit, and standard logic. So for this tutorial, I'm going to be using the frequency meter sample design that you could find in Open Example underneath VHDL designs. And before we get our report, let's go to Design, Settings, and make sure underneath the HDL that you're using to have Enable Debug so we can have read access to our design objects. From there, we're going to go to Coverage Profile and make sure ACDB coverage is on and make sure toggle is checked. Underneath ACDB coverage, there are additional toggle coverage settings. Here we have filter settings for toggle coverage, and in the advanced settings, you're able to change the definitions of the rising and falling edge. You can also count all coverage item hits, since by default, toggle coverage stops at 1 and it only counts the transition once before it stops. And you could choose to ignore or not ignore delta cycles, as well as add object bins with the high impedance value. You can also change the computation type, and you could choose to count or ignore unknown values in transition. So I'm just going to keep these all at default, hit apply OK, then we're compiling all to apply these settings. Once that's done, we can initialize and run our simulation. Once that's finished, we can now generate a report. Simulation, ACDB coverage, generate report. We can see we have a toggle coverage setting here, known as shown item type and toggle coverage. I'll get to that later, but I'll leave this unchecked for now. Now I'm going to go to General, choose where you want your output file to be saved. I labeled mine default mode, and make sure toggle is checked. From there, hit generate. And now we could see how the report has been generated, and we can open it from there. I'm going to open up default mode. All right, now that we have that open, we could see here we have our toggle coverage summary page right here. The first row is the toggle coverage row, and it shows the percentage value of the toggle coverage of the object, which is basically the percentage shown for the ratio of the toggle bins. And so for the toggle bins row, this is basically the number of transitions that occurred in the given scope versus the total number of transitions that can occur in the given scope. And then this row is the signal bits row, which shows the number of traced signals. So this is the number of traced signals that were toggled versus the number of total traced signals. And then if we were to go here to the toggle coverage table, we could see that there's a row for the name of the object, the transitions, and the toggled column. We can see here, if we were to expand this, that we could see that this is fully covered as indicated by the green, and the red shows that it's not fully toggled because both transitions have not been hit at least once during this simulation. And now, if we were to go back to simulation and generate another report, and you were to click on Show Item Type and Toggle Coverage and generate again, you would get this report here. I labeled it Item Types Displayed. And from here you can see that there's an additional column that has been added called Type, and it shows what type of item each object is. So we could see that nsim is a Boolean, and we could see how all these LEDs are all standard logic vectors. And if you wanted to see how many times each signal bit value has transitioned during simulation, rather than just the one limit, make sure to end a simulation first and go to Design, Settings, and click on Count All Coverage Item Hits. Apply OK. And once you initialize and run the simulation and generate another report, you're going to get this report. I've labeled this one All Hits Counted. Now, if we were to go back to the toggle coverage table, if I were to expand this, we can now actually see that instead of the one limit, we could see the actual total number of transitions that were hit during simulation for each signal bit. And now if you wanted to generate toggle coverage where you consider just one transition as a fully toggled signal, you would have to go back to Design, Settings, and you are going to change the computation setting to count all edges as 1 bin. Apply your settings, and then you would initialize and run your simulation again, generate the report, and you would get this report here. I've labeled it single edge. Now we were to go here to the summary. We can see that the toggle coverage percentage is greater than the default mode percentage, and that's because we have excluded some toggle bins now. And we could see in here in the toggle coverage summary table, if we expand this here, we can see how endsim is now considered fully toggled, because even though it didn't transition from high to low, we could see here indicated by the eye that this transition has been ignored because it transitioned at least once from a low to high value. And finally, if you wanted to include the high impedance value transitions, you're going to go to Design, Settings, and add object bins with Z value. If you wanted to do the single edge computation as well, you would go to Count Edges with Z value as 1 bin, and then you would hit Apply OK. After initializing simulation and running the simulation again and generating a report again, you would get this report here that I've labeled Toggle Z. And now we can see in the summary that the toggle coverage percentage is way lower, and we can see that none of the signal bits have been fully toggled, and that's because we've added more possible transitions to the computation. So now we go to the toggle coverage table, and we could see how the transitions to and from the high impedance value have been added to the table. And as we expand here, actual LEDC, we can see that during this simulation, none of the transitions to or from the high impedance value were hit, which is why this value is actually not considered toggled, whereas in default mode, it was considered fully toggled. And now if you wanted to be able to get toggle coverage through a macro script or through the command line, make sure when you compile your files that you pass the debug argument, as well as passing the debug argument in the asim command or alog if you're using Verilog. And then you want to pass the debug argument here, as well as the ACDB and ACDB cov with the toggle parameter to get toggle coverage data. And then you need to have this toggle command line as well. And from here, you could pass arguments. So if you wanted to do toggle Z, you could do the toggle Z mode here. If you wanted to count all the hits during simulation, this would be the argument to pass. And if you wanted to just count single edges as fully toggled, you would pass single edge. And if you were to do toggle Z mode, you would just do _Z. And that concludes it for this tutorial. I hope this gives you guys a better understanding of this helpful code coverage type, and thank you guys for watching.